In this next problem, it says that a statistics student wants to verify the claim that in a certain Fortune 500 company, the average salary of female employees is different from the average salary of male employees. And 2 samples of male and female workers were obtained independently and analyzed. And so we have this Excel file that has data from the samples. And that's all that it tells us, other than that we should assume the samples are from normal populations. So we're going to go into this Excel file and try to figure out in our samples which sample had a larger sample mean, and then try to use those sample means and things to figure out what we can conclude about the average salaries in these 2 groups, these 2 populations. So first, let's find our sample means for these 2 populations. So I want the sample mean for the group of women and the sample mean for the group of men. So to find my mean, I would do average and highlight the values. So women will be the average of A3 to A12. And for my sample mean for men, I would do the average of, D3 to D15. So let's see, these salaries are in thousands of dollars. And so that means that the women's salary, if I wanted to write this in thousands of dollars, I would multiply by 1,000. And I can drag this over to write the men's salary in thousands. And I'm going to write both of these in dollars. So the average women's salary is $57,200, and the average men's is $69,338.46. So the men's sample had a larger mean. So my sample mean is larger for the men. So what I might wonder is if these samples give me enough evidence to conclude that men in this company, on average, have higher salaries than women if I were to look at the whole populations. So to figure that out, let's make men my population 1 and women my population 2. And that means that my null hypothesis will be that, mu1 is the average for women. Let's maybe first think about the alternative hypothesis. So I want to see if I have enough evidence to say that the men's average is larger than the women's average. Oh, I put this the wrong way. Men are population 1, so this would be that mu1 is bigger than mu2. And so my null would be that mu1 is at most mu2. And these hypothesis statements depend on what we set up to be population 1 and population 2. If I labeled these differently, then I would have different hypothesis statements. So if I rewrite these hypothesis statements, my null will say that the difference in these means is at most 0, and the alternative will be that the difference in these means, these mu's, is bigger than 0. And so looking at this looks like it will be a right-tailed test. Okay, and it's this right-tailed test. I don't know the sigmas. All I have is the samples. And so I know that my test statistic is going to be a t. So since we have the data, we can use the data analysis tool to do these calculations for us. The issue is we need to decide if we're assuming equal variances or unequal variances. And I told you that in this class I will tell you which situation you're in, but in case you want to see how you would figure that out, I'll show you really quickly how you would go about figuring that out. So I want to test to see if the variances are equal or not equal. So what I could do in data analysis is I could go do the f-test to sample for variances. And I could tell it my 2 variables. So variable 1 is men, and I'm not going to include labels here. I'm just going to select the data. And let's say we're using an alpha of 0.05. And I'm going to put the output maybe somewhere down here. So In this part, I'm just testing to see if my variances are equal or not equal. And this p-value here is bigger than my alpha. So that means that I would fail to reject the null, and the null that I would be failing to reject is the variances being equal. So here I should assume that I have equal variances. So this is the point where if this was the homework or a quiz or an exam, I would tell you to assume equal variances, but this little f-test is how we would figure that out for ourselves. So now I go back to the test that I want to do, and I know that I should assume equal variances. So I go into data analysis again, and I'll do this t-test to sample assuming equal variances. So now let's see, my variable 1, I'm not going to include labels. I'll select the variable 1 data, and then I'll select the variable 2 data. And then our hypothesized mean difference is 0, and let's still use an alpha of 0.05. And let's put this output, I know we're getting lots of things here, but let's put this output down here. So this is for the test that we actually want to be doing, and we said that this will be a right-tailed test, which is a one-tailed test. So these are the values that we're interested in, and the one I really need to look at is this p-value. And this p-value is less than alpha, which means I should reject the null hypothesis. And so if I look back up at my hypothesis, I should reject the null, and I have enough evidence to conclude the alternative. And the alternative was that the average salary for men is bigger than the average salary for women in this company. And so we do have enough evidence to conclude that on average, men are making more in this company. And this, I know, seems complicated, but we're kind of putting together all the tools that we've learned so far.